Software Engineering Radio, Episode 8, interview with Eric Evans. Welcome everybody to this new episode of Software Engineering Radio. This is our second interview episode, and this time we talk to Eric Evans. Eric is the author of the Domaindriven design book, a book that has been very well received by the object-oriented software development community. The discussion can be broken down into three parts. In the first part, Eric talks about the main building blocks of domain-driven design. The second part discusses something called strategic design, a set of practices that helps you build consistent and well-structured systems. Finally, in the third part, we discuss about ubiquitous language, model-driven development, and domain-specific languages. We've recorded the interview using Skype. Welcome, Eric, to Software Engineering Radio. Before we actually talk about domain-driven design, you might probably want to introduce yourself a little bit and tell us something about your background.
Well, I have been doing object-oriented programming for about 15 years now, and most of that time has been in various complicated business systems. I worked on Wall Street for a while, and in Silicon Valley I worked in transportation systems and banking systems and currency transfer systems and various kinds of complex business applications using object-oriented technology. And so a good deal of my specialty has become modeling complex domains and implementing models in object-oriented software. And that's what led to my book, Domaindriven Design, was an attempt to capture for people the successful practices that I had seen or used, that I had used, some of which have been around for a long time, some of which are relatively new, and put it together into a coherent set of practices and with clear names, so that maybe we could have broader success than we have had in the past.
So your book has been received quite well by the community, I guess. So can you explain in somewhat more detail what the idea of domain-driven design is and what distinguishes this approach from kind of normal object-oriented what everybody else does?
A great deal of domain-driven design comes straight out of good old-fashioned object-oriented design practices, but it is not the same thing. For two reasons. One, because domain-driven design could be applied outside of object-oriented design. It really doesn't say that you have to make objects. What it says is that you have to start from an understanding of the domain and focus there first and build knowledge and refine that knowledge and develop a model that is your shared understanding of that domain, and build software based on that understanding and shape that software around that understanding. And what object-oriented software does is gives you the ability to render in software some concepts that are natural for thinking about businesses. And there are other paradigms, like, say, rule-based programming, that could also be done in a domain-driven fashion. But my background is object-oriented programming, and objects are also the mainstream of our current generation of software. And so, in effect, it is a way of doing object-oriented programming. But there's another way in which it's different, and that is that a great deal of quite object-oriented software is designed and conceived from a technical point of view. You can start out thinking about a technical problem, and you can come out with an elegant object-oriented solution to that technical problem. And the reason for the name domain-driven design is saying this is not the right place to start for most applications. Not all, but most. That's the difference, I suppose. It's more a matter of where the emphasis lies and what you think about when you do your design work.
Yeah, putting functionality of your business first and technology second.
Functionality and understanding.
Right.
Beyond just functionality.
Mm-hmm. So in your book you distinguish various parts of domain-driven design. Some are more related to programming techniques, others are more process-related or design-related. So there are, I think, 5 or 7 core building blocks you mentioned in the book, like entities, value objects, factories, these kinds of things. Do you think you can explain why they play such a central role and what they mean to developers, why they're important?
Sure. As you said, there's the book tends to bring together the different pieces that you need to make domain-driven design work. And one of the reasons I think that the technique hasn't taken off as much is because it is not particularly a way of programming or a process or a design methodology. It's sort of a philosophy that cuts across all of these. So that's why the book seems a bit of this and a bit of that in that sense. The building blocks are important because what I've observed is that people will come into a design problem and they will attack it pretty much from scratch. I mean, we're still just everything's an object. And what I've seen is that in well-formed models whose purpose is software, that there are certain recurring patterns that the model objects tend to fall into a relatively small number of types, and that it's very useful to push your model concepts to one of these. For example, the thing that most people love to talk about seems to be the distinction between entities and value objects. This, by the way, is not my original contribution. This distinction has been around for quite a while and been written about in other books.
Yeah.
And I think that it's gotten more attention in my book, and that's all to the good. But to distinguish between these two, basically one of them, the entity, revolves around identity and continuity, and not around the properties of the thing. So in a metaphor, if you think of a living person, there's almost no attribute of that person that exists throughout the lifespan of that person. And of course, the entity that we associate with that person exists, in fact, long after they're dead and their body is gone. So there's no actual property that this person has. But there is an identity, and it ties together things that we think are important. So the same is true of objects. And you may have, let's say, in your system, and some of these objects correspond to people, so that's easy to think about. You might have a customer object, and your customer object may have importance in the sales-related part of your software. So you may track information about sales calls and historical sales volumes and so on, things that your salespeople need to interact with this person, contact information. All these things are changing. This seems pretty straightforward. In another part of your software, you may be actually handling the service to this customer. You may need completely different information about that customer for the purpose of providing service to them than you did for trying to sell things to them. Historical sales is not relevant. The contact person that you had there is probably not relevant because it's probably somebody who in a procurement role rather than in a operational role. So you have a completely different model of this customer for purposes of service, and yet it's the same entity. But contrast this to a value object. in a value object, if it's well-formed, you don't care about identity. There's no meaningful identity at all. A good example of a value object, a kind of canonical example of a value object that I tend to use is color. So if you want to describe the color of something, you say it's red, you say it's green. You don't care if the red color that you were referring to yesterday is the same particular red that it is today. I mean, you care that it's the same color, but that's a value, a property that you can describe. You don't care if it's the same red object. Even in terms of how you would handle the implementation, do you care about history? Do you, when you change this object, do you throw it away and get another one? The more of that kind of thing you can do, having immutable objects that just are what they are, and when you no longer want them, you throw them away and get another one, your system will be a lot easier to manage, because you can make statements about these objects that are firm and always true statements, which you can't do very easily about an entity, not in the same way. Entities are a lot harder to manage, and also a lot of the meaning of a model comes from those value objects. People tend to confuse them with data transfer objects.
Yeah, that's because of a naming conflict that has been resolved quite recently only, right?
That's true. That did aggravate the problem, but I think that naming conflict arose in part because people already confused the two concepts, and hopefully this rename will help to clarify things in people's minds. You could well have a data transfer object based on an entity. So you might send some data structure from one system to another that represented some key information about your customer, and along with the customer ID. And in the other system, it would match that customer ID up to the customer in that system, and it would start to use that information in the way that that other system used customer information. Another distinction that I made in that building block section is I talked about repositories and factories and services. Well, anyway, you start making these distinctions, and you start to have a model which has these kind of objects in it that are recognizable types. And someone knows some properties that they can trust about this object. If I tell you it's a value object, you can assume all kinds of things. You can assume that this object will not change, that it represents some information about something rather than the continuity of an identity. If I tell you that this is a repository, you know that it's probably an abstraction layer that hides database access of some kind, but you don't have to know the details of that database access to use the repository.
Okay, so after coming up with these basic building blocks like entities, value objects, services, and the facilities that manage them, repositories and factories, there are some more like architectural or design things like the anti-corruption layer or pluggable component frameworks, which then probably serve as an architectural base of the technical solution, right?
Right. So there's a whole, what I referred to as strategic design. I tried to actually avoid the word architecture in the book. You'll find it isn't used very much, because I found that it isn't a very clearly defined word, and means so many things to so many people. So I referred to it as strategic design, because these are kind of design decisions that affect the trajectory of the whole project and can have a big impact far beyond the particular area in which they're used, or rather far beyond a particular area in which a typical, say, object or small set of objects would be used. And yes, I've found that certain kinds of strategic design decisions or architectural decisions can completely derail an attempt to do domain-driven design. So over the years, I've been involved with a lot of projects that were very successful, and I've been involved with some projects that were total failures, and I've been involved with quite a few projects that kind of muddled through and succeeded, but were not very exciting. And I looked to see, as I was thinking about writing this book, I really reflected on why we ended up on those different paths. On some projects, you find that you don't have some of the basic skills. On all these projects, people had the intention of creating a domain model and using that to give them the advantages domain models are supposed to give you, the flexibility, the maintainability, the ability to create something complex without getting overwhelmed. So sometimes they didn't achieve that because they didn't have the basic skills to kind of create a good object model, implement it effectively. Tightening up a model and implementing it effectively, that's what the building blocks are all about. Also, having a bit of uniformity there, a common language and a common set of very basic concepts that help a team work together. So, as I say, some teams failed for those reasons. Some teams failed because they never found the model that really broke through and worked. And so there's a section in here called Refactoring Toward Deeper Insight. It's more about how do you explore and find a really piercing domain model, and how does that evolutionary process work. But some of them did all these things right, and they still didn't achieve the goal. And sometimes it was because of things that were beyond the control of an individual developer, or even sometimes a team. Sometimes it was an architectural decision made either at the whole team level or often for an entire department that just basically undermined what they were doing. And there's quite a variety of these. I tried to focus on 3 aspects in the strategic design section. And the most important one is the one you referred to when you mentioned the anti-corruption layers. That's what I call context mapping. The basic thought there is it's really more of an observation that in any sizable project you will have more than one model. Mm-hmm. And if you don't consciously manage this, the different models will contaminate each other and will muddle, and what you'll end up with is a muddle. You won't have the clarity that a model needs to be really useful, because you'll have concepts that are mixtures of these different models. Well-run projects usually do informally distinguish between the areas of the system that are applying different models. As I mentioned, most of what's in the book has been our successful practices from the past. But this is one which has been done in a kind of intuitive way on some projects, but not on all projects by any means, and not consistently. And because it's been done so intuitively, there's no vocabulary at all to describe what's being done. In some ways, I think that context mapping process in Chapter 14 might be the most fundamental contribution of the book, the one that's the most missing from what most people do.
Your book also contains a couple of, maybe let's call it tips or best practices for the design process. One thing I really like is the ubiquitous language. I use it all the time in the context of meta models. You want to elaborate a couple of sentences on these?
Yeah, I would say that in addition to context mapping, ubiquitous language is the other really fundamental thing. What it means is that one way of putting it is that rather than focusing on artifacts such as, say, a UML diagram or whatever that reflect the model, that you focus on the language of the project. And your goal in modeling is really the evolution of a better language to talk about your domain. And this language is not just used in conversations among the modelers. It's used in conversations between developers, conversations between domain experts and developers, conversations about the system. But it's also used in the code itself, so that you name your objects appropriately and the relationships between them so that they correspond to the way you would talk about them in the tests and everything. You've got this evolving language that runs through everything, which is what ubiquitous means. So it becomes a ubiquitous language that is anchored in a conceptual model of the domain. It's kind of related. One of the movements that tries to carry this to its logical extreme is the domain-specific languages,
right?
Which I find very interesting.
I would have mentioned this topic later, so
okay, let's come back to that one.
Yeah, I mean, now you mentioned it. So, do you think there is a relationship between your approach and domain-specific languages and all this model-driven development stuff? And also, what's the importance of modeling? If you talk about modeling, I always think I understand, also from your book, that you see basically well-written code as the model, whereas other people think the model is, more like a UML diagram. What do you think is the relationship between those? How important is UML-based design in your approach?
Okay, that's a good question. Let me start by saying what I really think a model is. I think a model is really a set of related concepts that can be applied to solve some problem. And that's a very abstract definition of a model, but I think it is, in fact, the definition of model. And all of these other things are specific artifacts that are used to communicate about a model or to describe or specify it. But the model itself is a set of abstractions, a set of rules of how these abstractions interact to solve some problem. And it's useful to strip back to that original definition of model. We've gotten so far away from it. I think in the early days, when the term model first started being applied to the software realm, I assume was when Simula came along. That's before my time, but I think that's probably around the time that this started to be applied. And so, because they had created a language that was specifically designed to express models, over time it became synonymous. And so people from that kind of background, that kind of historical path, sort of view the code as being the model. And that's probably the closest to my own, in the sense that I was a Smalltalk programmer first. So I think of well-written code as being the most important expression of the model. But I don't think of it as the model itself. And I do think that fine distinction is an important one. So other expressions of the model, in fact, exist on the project. One is UML diagrams, which I find useful, especially if they are not complete. The more complete they are, the less useful they are. Because what makes them useful is how they can be used to highlight the important things and distill the conceptual parts and separate them from the more incidental parts and focus attention on something. All of these things go away when you try to, let's say, generate a program based on a UML model.
This together J problem where you have, for each class in your code, you have a box in your screen with all the details.
Exactly. Then it's easier to look at the code for me.
Yes, for me too.
And the two are indistinguishable in their content. To me, a UML diagram that's well crafted gets rid of the clutter, focuses someone's attention on the key aspects, brings out the abstraction more vividly than it would be in the code. But you can't generate a program from a UML diagram like that. But you can communicate important things to another person that way.
So if we look at the model-driven domain area, then when people try to capture the complete semantics of something with a specifically crafted modeling language, do you think that fits well with your domain-driven development style?
So you asked, in fact, a few minutes ago, what was the relationship between domain-driven design and domain-specific languages or model-driven architecture or these other approaches. Yeah. What I would say is, I hesitate to say this because it sounds so grandiose, but I actually don't mean it that way. I would say that both of those are attempts at finding better ways of doing domain-driven design. So I
agree completely, yeah.
So the fundamental idea of domain-driven design is that we enable ourselves to focus on the business or whatever our domain is, and that we aren't focusing primarily on technical solutions to technical problems. And that's what both MDA and domain-specific languages are trying to accomplish. So far, I haven't seen much in the MDA realm that has been useful to me in this way. Unfortunately, it seems that, the transformation layers and so on seem to add in a great deal of concentration on the technical. The biggest problem there for me is that you have to express the model in UML, which I find to be an awkward language for that fine detail expression of models. So perhaps someone will take some of the things that the MDA people have worked out and maybe they'll create a new modeling language to lay on top of it, or who knows what will happen. I mean, I think experiments are great, and I hope that people continue trying all sorts of things. It's way too soon to standardize on something, if you ask me. We haven't had a period of wild experimentation that hit on good solutions.
Yeah, and I think that tendency is always more or less obvious, because the MDA copyright OMG thing, which uses UML for all that stuff, is not used by too many people. Most people build their own languages to express specifically what they need, and that's probably more in your spirit.
Yeah, that, and which brings us to the domain-specific languages. Domain-specific languages is something that I find is very exciting. I feel like surely that is part of the future of domain-driven design. But I think there are a couple of blind alleys that people tend to go down there. One of them, for me, is, this is a big one, that most of the particular techniques for creating domain-specific languages create this very sharp line between those who develop the language and those who use the language. Mm-hmm. This seems unnatural to me. In the successful projects that I was in, as we would address domain problems, we would modify our model, and let's say we were working in Smalltalk. The Smalltalk code would be refined to the point where we could make statements in Smalltalk that looked almost like a domain-specific language. Mm-hmm. But furthermore, as we would address a new problem, we wouldn't just say, okay, we'll use the language that we have to solve this problem now. Well, we might if it would fit. But very quickly we would drop through to saying, how do we have to change the language to make it possible to express this situation we're in very concisely and clearly? If you've got this very big separation between those who use the language and those who create the language, you don't have that kind of closed loop. So the language itself doesn't evolve to handle the domain, the deeper and deeper in a more powerful way. This is the problem that I see. I could see that there are certain kinds of domain situations where this is perfectly fine, where it's naturally separated into two different users. I mean, to take one example, if you're creating some kind of industrial equipment that's highly programmable, so you create a domain-specific language that will allow engineers in a factory, let's say, to program the machine to do the things that they need it to do. Well, in this case, the range of things the machine does is limited and very well defined, and the range of things that the engineers in the factory will need it to do is something that those people are not going to be able to be involved in. It's just the right situation to have this kind of this kind of approach that splits the two apart. But if we're talking about, let's say, I don't know, banking software, the idea that one group would create a set of primitives or relatively high-level concepts even, that the other group would then use, I just don't find that it works that well. I think that it starts to break down because the underlying model hasn't evolved long enough to really give them what they need.
This is actually a really good point, because most of model-driven development today concerns technology. So you automate, working with J2EE, or you automate working with some other component platform. And in this case, it probably does make sense to have this group of people who defines the language, because it's limited by the technology. That's the machine metaphor you just mentioned. And the other group who uses it. But if the DSL covers domain concepts like banking, radio astronomy, vehicle management, or these kinds of things, then it's probably absolutely, just what you said, that it's important that the domain experts use the language and evolve the language to reflect their deeper understanding.
Yeah, or if not the domain experts themselves, because sometimes domain experts don't have the kind of rigorous model thinking that it would take to design this language, but to have this partnership, this close collaborative partnership between software experts and domain experts, that are constantly evolving the model and the language that's used to make expressions in that model. That I think is, if we can get something that gives us that, a domain-specific language technology that lets us do that, then I think we'll really have something.
Okay, so before we wrap up, I would like to ask one last question. Your book contains a lot of patterns. You have written many parts of it in pattern style. On the other hand, it's not titled Domain-Driven Design Patterns or Patterns for Domain-Driven Design. So why is that? A while ago, the word pattern in the title was a good sales argument, right? And you decided not to do that.
Yes.
Why?
Well, that was quite a conscious decision on my part.
Yeah, I thought.
And it was one that maybe the publisher wasn't so happy about because, as you say, it was considered a sales point, and maybe it still is. But I felt that patterns, you're right, there are lots of patterns in the book, but I felt like it had gotten to the point where patterns were digested, and now what was interesting wasn't the fact that you're using patterns. It was what was the thing that this book was supposed to show you how to do. I could have called it domain-driven design in chapters, because the book is broken into chapters, and chapters is a wonderful organizing principle for a book. But very few books draw attention to that in the title. Now, this book is about domain-driven design, and in fact, in my case, it was especially important, I thought, and here's why. Because one of my basic drumbeats is that we get distracted from the central issue, which is the domain, to understand that domain and build software that really works within that domain. We get distracted from that by all kinds of supporting things, like the technologies that we do in fact need and that are so very interesting to us. But these techniques are means to an end, and the end is domain. Well, in the same way, if I had called this book Domain-Driven Design Patterns, I would have been getting distracted by the technique being patterns, instead of staying focused on the core, the important goal, which was communicating about domain-driven design. So that was why that didn't appear in the title.
Yeah, many people say that it's actually a sign of patterns maturity if it's not necessary anymore, to mention it. So they become really what they are, a means of expression, of specifying things in a very particularly useful or understandable way.
I completely agree with that.
Okay, so definitely last question. Anything you're working on right now? Another book coming out maybe soon? So what can we expect in the future?
Well, what I'm one thing I'm working on right now that I think might be interesting to people is there's a open source code library called Time and Money. One of the things that I found people asking for was examples, working examples, and I thought, well, I didn't really learn object-oriented design from a book so much as I did from working with well-designed code. And so from many angles, I thought we need some good code libraries out there that are kind of designed around this philosophy. Mm-hmm. And some of them, and also there are some kind of gaps in what we have to use too, so that we spend an inordinate amount of time doing kind of low-level things. And two of these domains that seem to be weak in the Java world were time, because of the pretty well-known deficiencies of the Java util date and calendar classes.
Yeah.
And money, where there are a lot of subtleties of working with money that's different than working with numbers of other kinds. So we set out to do this, to fill this gap a bit, and do it in a completely out there for everyone to see, so that they could be involved, watch it evolve. So there's a SourceForge project called Time and Money. That's one of the things that I think people will find interesting. And we get to use it as a bit of a test bed for ideas, such as see how far you can push this idea of the domain-specific language that's really implemented in Java. Mm-hmm, mm-hmm. Things like that. But at least trying to make this code base supple, in the sense that it's something that developers will enjoy working with. It will feel right to them. It will give them flexibility where they need flexibility. It will be simple and out of their way where they are not interested in getting into the details, but at the same time completely open, so that to whatever extent they want to, they can dive in. We put it under the MIT license so that it's as free as can be. People can change it, they can use it in commercial products, whatever they want. It's very open.
Okay, anything else you want to mention?
Can't think of anything right now. The ubiquitous language, context mapping, those are the places to start. And I do appreciate the interview. It was a lot of fun.
Yeah, thank you for being on the show. And good luck with your whatever you do next. This was another episode of Software Engineering Radio. The Software Engineering Radio team wants to thank Henning Pauli for providing the music, as well as Libsyn.com for hosting and bandwidth. For more information on the podcast, past episodes and feedback, go to se-radio.net.